Hello everyone, let's talk about parallelism now. So why and when to use parallel execution? Many people think that parallelism is a good thing. Of course, it improves response time for big queries because for one task, several threads work in parallel to complete it faster. Especially this is appropriate for data warehouse workloads when you have big data. However, parallelism has its related cost. When you create many parallel worker threads, it gives more pressure on CPU because CPU should handle more tasks and CPU idle time significantly decreases. Also, many parallel worker threads might block each other and cause bottlenecks. As a result, you might experience less throughput and session concurrencies. Especially in OLTP servers, if small queries are run with parallelism, they might actually run slower than without parallelism. Okay, therefore, at the beginning, I want to point out that parallelism does not match for all the cases. If we talk basics of parallel execution, firstly, it allows horizontally partition data. Then, distribute partitions among CPUs. And for each partition, we can do operations independently and parallelly. As a result, we can achieve high scalability. In SQL Server, we set degree of parallelism by max stop setting. This is maximum degree of parallelism per operator, okay? Not per query, but per operator. For example, table scan is bringing data by using parallelism. You can see small parallelism mark here. If max stop is equal to 2, this table scan operator can use maximum 2 parallel worker threads to complete its task. The meaning of max stop is this. This is not degree of parallelism for the whole query, but for any single parallelism-aware operator. For the parallelism to work, you should have at least 2 processors or cores, and they should be online. You can see I have more than one visible online CPUs, so my hardware can do parallelism. In addition, the maximum degree of parallelism advanced configuration option must allow the use of at least 2 processors. You can see here it is equal to 0, which means we are relying on SQL Server to choose degree of parallelism based on available resources. 0 does not mean that parallelism does not happen. 0 means that parallelism can happen and the degree of parallelism depends on SQL Server to choose. If you want a parallelism equal to 2, you can just set it to or 3 or 4, okay? So, there is one more important parameter, cost threshold for parallelism. Parallelism is used when the estimated cost of a query is higher than the value defined in this parameter. Let's generate the data and run the select query, which does the operation with parallelism. Firstly, there are parallelism-aware operators and there are parallelism-related operators. Here you can see table scan and aggregate compute scalar operations are being done with parallelism. You can easily spot whether there is parallelism by seeing this yellow mark. These operators are called as parallelism-aware operators. There is parallelism operator also here, specifically for parallelism. Here, gather streams parallelism operator. From here, you can see how many threads are being run in parallel and how much data is being processed in each thread. How many batches are being processed and how much data is being read and how much CPU time is being spent by each parallel thread. Usually, all the threads should process nearly the same amount of data. If some thread is performing less, there should be some load on that specific CPU. Thread with 0 is coordinator and always equal to 0. Let's try to understand how these operators are performing internally like this. Suppose degree of parallelism is 3. In this case, 3 parallel threads bring on average 5 rows in parallel by using table scan. Then, by using the same level of parallelism, hash match and compute scalar operators do aggregate operators for this each batch. If you don't know how aggregate operators work, please refer to previous session. Then, when it comes to gather streams operator, all the batches are gathered as one batch and passed to last operator. So here, gather streams means gathering the data from multiple batches and output one batch. We understood about gather streams. There are other parallelism operators. First, repartition stream. In the stream, batch data from multiple parallel threads are consumed and distributed to another parallel threads. Last one is distribute operator, where operator takes single input and produces multiple outputs. In parallelism, these right side threads are called as producer threads, while left side are consumer ones. So now we are clear about parallelism and how it works. Let's continue with our example. If we open XML of the plan, we can see degree of parallelism and cost of this query. This cost should be above cost of parallelism threshold. Let's increase this threshold and rerun. As you can see, in this case, parallelism is not being used as the cost is lower than the threshold. We will return the threshold. Finally, I want to finish this session troubleshooting one parallelism-related performance issue. Let's generate one example of parallelism. Here you can see by using parallelism, we are doing hash match join and doing gather streams parallelism. Here our query is finishing within these seconds. Now let's try to compare the performance with a case where there is no parallelism. To enforce a serial plan, we use hint. Interestingly, here again the query is finishing within the same seconds. Why? Because as you can see, for parallelism operations like distributing the data among threads and gathering, SQL Server takes time. Therefore, for some situations, the performance of serial and parallel plans becomes the same. In this situation, we had better use serial plan as parallel plan because it makes CPU more busy for unnecessary parallel threads. If you want to improve this kind of queries, you had better create index and use where clause. For example, I create this index on ID for both tables because ID is being used in join operation. Then I add where clause. In this case, as you can see, our query is finishing within seconds. I'm not saying parallelism is bad. Parallelism is very helpful in many queries, especially in OLAP servers. You should properly design your application and queries for better performance instead. Happy learning!